Now, on one of the sample exams, there's this problem here. It turned out to be a very difficult problem for the class, which makes it an excellent teaching problem. I've got a copy here on the document camera. Now, I'd like to work this quickly so that you can avoid the mistake that most people made when they took this exam. We have a simple circuit looking like circuits we've seen before, with the exception of that nichrome wire. Now remember, the nichrome wire you actually handled in the first tutorial on circuits. You found that it got warm, but it didn't melt like if you had taken a regular connecting wire and put it from one side of the battery to the other. That would have melted the wire. Nichrome wire has resistance, and the longer the wire, the more resistance it has. Indeed, it's very linear. Twice the length is going to have twice the resistance. Now, we're asked to predict what the voltage would be across bulb A, bulb B, and bulb C when we change the length of nichrome. Now, the first one to fill in is bulb B. It's parallel across the battery, so it just doesn't care. It's got 1.5 volts, come heck or high water. The only way you can change that is if you short out the battery. Now, what about bulb C? Well, I know that the voltage across bulb C is equal to the voltage across the nichrome because they're parallel. And so that means whatever I've got across the nichrome, I've got across C. That make sense? And now, to find the voltage across A, I use the fact that the voltage across A plus the voltage across C has to equal the 1.5 volts of the battery. Or I could have said the voltage across A plus the voltage across the nichrome is equal to the 1.5 volts of the battery. Either way. You see that? There's a path from one side of the battery to the other that goes through A and C. So that means that A plus C has to equal the battery. So that means here I've got 1 volt, here I've got 0.9 volts, here I've got 0.86 volts, here I've got 0.83 volts. Because 1 plus 0.5 equals 1.5, 0.9 plus 0.6 equals 1.5, 0.86 plus 0.64 equals 1.5, and 0.83 plus 0.67 equals 1.5. We on the bus? Now here's where it got hard. We changed the length of the nichrome from 40 centimeters to 3 miles long. And when I gave this exam, everyone raised their hand, and when I went to them, they said, "How many centimeters in a mile?" And my answer was, oh, I'm sorry, there's a typo there. It's not 3 miles of nichrome, it's 30 miles of nichrome. No, it's 300 miles of nichrome. No, it's 3,000 miles of nichrome. It's big. That's what I meant. Big nichrome. Don't be converting miles to centimeters, okay? Now, before we answer this part B that everyone got wrong, let's go and answer part C, which everyone got right. If I just take the nichrome out and leave the empty socket behind, the gaping hole, the voltage across B is going to be 1.5 volts. The voltage across the battery is going to be 1.5 volts. Now, what can you tell me about the brightness of A compared to the brightness of C? Equal. They're equal. They're in series. And they got that up to 1.5, so that's going to be 0.75 and 0.75. We good with that? Let's go back to the hard one. Okay, let's go back to B. Now, the voltage across the battery is going to be 1.5 volts. The voltage across the bulb B is going to be 1.5 volts. When the current has to choose, after it goes through A, the current has to choose between going through bulb C or going through 3,000 miles of nichrome wire. What can you tell me about the brightness of bulb C compared to the brightness of bulb A? They're going to be the same. Okay, all the current that goes through A is going to go through C. Maybe one electron named Fred is going to go through the nichrome, but I doubt it. Okay? And so that means if A and C are the same brightness, and if they constitute a path from one side of the battery to the other, I have to have 0.75 volts here and 0.75 volts there. In other words, A and C aren't glowing any differently than they were in the last part of the problem. Now, what is the voltage across the nichrome? Tell your neighbor real quick. What is it?
1.5 volts.
Okay. Now, the answer is 0.75 volts.
Oh, yeah.
Because it's in parallel with bulb C. It's got to have the same volts across it that bulb C does. Now, many people got this wrong by saying, they were careless with their words. They said, oh, the bigger the resistance, the bigger the share of the 1.5 volts. Since this is a huge resistance, it gets the full 1.5 volts. Well, that's only true for things in series. And bulb A is not in series with that nichrome. A is in series with the network of the nichrome and C together. And a network that's parallel has resistance less than the least. And so that network's going to have a resistance that is a tiny, infinitesimal amount less than the resistance of bulb C. And so in essence, it's the same as A and C in series. Okay? We have another path. The path is so ugly that virtually none of the current chooses to go down. Check that your neighbor's okay with this answer, please.